Now we're moving on to three-dimensional shapes. So we'll be looking at measurement in terms of surface area and volume. So what you'll see is that I've divided up the information into two separate tables. In this table, what I have is polyhedrons. We talked about polyhedrons in the past. Those are three-dimensional solids who are composed of edges, faces, and vertices. And these faces are flat. So that's very important. These are various examples of polyhedra. We have a general prism, and within that category you can have things like a triangular prism, a rectangular prism, most common in construction. What's interesting to note is that the formula for the volume and a surface area of a prism, which I've denoted here, you can see that they're very, very elegant formulas. Like, you don't have to write down the entire alphabet to write a formula for for volume or surface area. As long as you know three features of a prism, which include the area of the base, the perimeter of the base, and the height of the prism, just with those three quantities, you are able to succeed in terms of finding volume and or surface area. So what I'm saying is, these two boxes here with the triangular and the rectangular prism, you don't have to know these formulas. All you really need is this general framework, and you can do every question. Then we move on to polyhedra that involve pyramid shape. So you have a general pyramid, which is basically a third of the area of the base times the height for the volume. But notice I put here surface areas dot dot dot. These are pretty much treated as a case-by-case basis. Most likely you're not going to get a surface area of a pyramid on a test unless it's really, really easy. My goal is not to waste half the test for you doing a bunch of trigonometry to find all the areas of each of the lateral surfaces here, the slanted surfaces. So those are all just shapes that are polyhedra. The next table, which is the last set of formulas that you need to know for the test, you don't have to memorize them. You can have them right in front of you, remember. If you have the ability to print it, I'd print it. Or maybe if you just have it on your screen or something as you're writing the test, you can flip between the two tabs and use the formulas. Anyway, we have cylinders and cones here. That's what you got here. You got cylinders, which actually are the same formula as prism. These two formulas for the general right cylinder are the same formula as for the polyhedra that are prisms. Then we have cones. Cone has the same formula as the pyramid when you write down area of base. And then you can substitute that area of the base with a circle, and you get a right circular cone. Finally, down at the bottom here, we have a sphere. One last thing I want to mention regarding all these formulas is, just because I give you how many there are here anyway, I think there's 11 of them, 11 shapes that I've shown you, or categories of shapes, you may need to kind of invent your own little formula. Like, I'm not trying to destroy anybody here, but let's just say, for example, let's take this sphere here. We'll do a question today where it's not a sphere, it's half of a sphere or a hemisphere. So just be prepared that you might have to adapt a little bit the formula for the situation at hand. So what I'm going to do for the rest of today now is just basically practice some questions. So for those of you that have read ahead in the book, this is an opportunity for you to check your work, or you can just do it fresh and new, just like we're going to do together. So I'm going to descend down the list of questions here, and we might not do every single one today. My intention is not to like marathon you through a book, especially on a Friday. Come on, right? Like, that's what you want. I want to just I want to do questions nice and slow. I want you to take your time to try to do them as well, and we'll just see how it goes. So I'll go a little bit easier on you in the first hour, and then we'll take a break, and then in the second hour maybe we'll do some more challenging questions. So here's question one. There's the sphere here, and we're given the radius. There's the radius, 16.5 feet. Let's just zoom it in a little bit. The radius is 16.5 feet, and you're asked to find the surface area and the volume of the sphere. Now, in basketball terms, this is a layup, okay? This is like the easiest question. As long as you just know the formula and put some numbers in. But make sure that when you put quantities in the formula, you want to be careful to look for things like the correct units and other little twists and turns. Like I said, if it's not a sphere, maybe it's a hemisphere or something. So yeah, would you be so kind as to look up the formula in the table? So if we go back to the table here, let's take a look here. There's the sphere. So I'm just gonna, thank you, Denny. So Denny's just dropped the formula for the surface area. And let's just, whoops. I'm managing a couple of tabs today. This is, I'm at the other location today. So it's a little bit entertaining learning how to use this device. Basically, usually my monitor at my home office is it's just a regular monitor, like a 30-inch or whatever it is. But now I'm at my family's home, and I got a like 30-inch, or sorry, a 40-inch TV as the monitor, so it's like right in my face. Anyway, there's the volume and the surface area formulas. How about I give you a couple of minutes, and I'd like you to just do the calculations, okay? So please take some time to do those calculations. Hi, Shalon. So I'm gonna just stop talking for about a minute or two. I'll stop for 2 minutes, and you'll do these calculations. That's okay. So again, I'm stopping my conversation for about a minute or two. I'd like you to do these calculations, please. Okay, so we're going to continue now with our solutions. So let's take a look here and see what you got. Can someone want to report either the surface area or the volume or both in the chat? Anybody have calculations for those? Yeah, that's very good, Denny. That's the surface area. Anybody have the volume? Anybody have a volume there? Okay, I'm going to put the answer up. So let's take a look here. Yes, Denny, thank you so much. Hopefully it's not just Denny answering questions today. So thank you, Denny. In a good way, I mean. So you notice that the answer that was reported in the chat was 3421. Now I rounded it here to 3420. And the reason is because the question says 3 significant digits. So for 3 significant digits, we want to see to the nearest tens. And then for the volume, which is also what you would get on your calculator as reported in the chat in cubic feet, you want to go to the nearest 100 here because it's 3 significant digits. So although your calculator might report 18817 on the screen, you need to round it to 18,800. So I will post these solutions, as you know and familiar with, at the end of the lesson today. But in the meantime, let's move on to the next question, and let's take a look and have some fun with the next question here. So we're going to do number 2. We have a volume and a total surface area for a right circular cone. Now, no, you did very well, Denny. That's excellent work. Excellent work. So find the volume and the surface area of this cone. There are formulas in the book for volume and surface area. So I'm not gonna. I find if I slide back and forth between the two, between the table and here, it's gonna be a little bit too much going back and forth. So I'm just gonna just type the formulas again. So the volume of a cone is sorry, I'm just cleaning up something on my desktop. The volume is 1/3 pi r squared height. Don't worry, I know these formulas inside and out. I'm not worried about knowing formulas here. Now the surface area is 2 parts. There's pi r squared, because that's the circle at the bottom. But then there's the slanted or lateral area, and for that there's a pi rs. When you look at that, you see this letter S here. Because on the figure there, you know immediately what the height and the radius are. Like the radius is right there. It's 19.5 centimeters, and the height is 32.7 centimeters. But there's this quantity S that we have to negotiate and figure that out. So what we're going to do is talk about S for a bit. It's really easy. S is the quantity called the slant height. So if you go over here and you draw a diagonal like that, that's S. So S actually, if you look at the quantities here, it's H, R, and S. So there's a formula there for you to get S. How would you find the slant height then? What could you use to find the slant height? Any volunteers there in the chat? What could you use? What mathematical formula could you use to find the slant height? It's so quiet today. What kind of triangle is that? Yeah, that's the right answer, Denny. Very good. I'm just asking here first, though. So Denny had.
Pythagoras?
I'm sorry.
Pythagoras there.
I can't understand what's happening. Does someone have their mic on?
He said Pythagorean theorem.
Oh, Pythagorean theorem. Sorry, it just it was really muffled, the sound. Okay. Okay, yeah, better to type it in the chat. Type it in the chat because for some reason it's coming out. The audio is not very well today. Thank you. No, thank you, Shalon. Yeah, it's Pythagorean theorem. That's r squared plus h squared. So if you apply the Pythagorean theorem, I've seen in your assignments that you're very well versed with using the Pythagorean theorem. So I'm just going to report the slant height here because I don't think you need me to write ABCs anymore. So there you go. There's the slant height. I got 38 and change, 38.07 centimeters. Now, if we go with the volume first, which is what Denny had done, which is very good, you would have here, let's just expand our real estate a little bit. The volume is going to be 1/3 pi r squared h. And we know the radius is 19.5, and then the height is 32.7. Now, Denny typed in the chat there 13,000, which is very good. That's actually the answer. I'm going to put an extra step here for a second. Actually, no, I'm just going to put the answer. It's fine. This is 3 significant digits. It's just lucky. It's just lucky that there's a significant digit here. That the 0 is here. Okay. I hear feedback. I'm not sure why there's feedback, but I'm gonna mute all the participants. Sorry. Okay. So that's the answer that was reported in the chat, and that's excellent. Yeah, it was 13,021. And we're going to go to the nearest hundreds. So that's why it's 130. This 0, you don't have to put the bar for me, but that bar on top of the 0, it tags it. It gives it like a label that it's significant. If you don't put the bar on the 0 here, don't worry about it, especially on a test. On a test, you'll see that I'm not as strict about significant digits as I am on assignments, because obviously the test, you don't have time to look pretty. You just have to get the right answers and move on. On the assignments, though, I'm obviously very, respectful and careful when I come to marking. Okay, so anybody calculate the surface area yet? Anybody have the surface area there? So we have pi r squared plus pi r, pi r s. S is 3807. Let me know in the chat there. Anybody have a surface area? Okay. I notice our audience is a little bit smaller today. I wonder if some people worked ahead in the booklet, or who knows. That's okay, Shalon. I appreciate it. You're always very helpful in the chat. I'll just rely on Denny more today, because Denny seems to be holding up the class a little bit here. So okay, let's put that surface area down. I got 3530. Sorry, this is cubed. There's a typo there. My apologies. The neat thing is that I didn't notice the mistake earlier. Oh, I see what you're saying. I got you, Ram. Busy week, eh? So we always have to check if the units are right. So notice here I had a mistake that I put centimeters squared for the volume. That's okay, because I found the mistake later, because whenever I write final answers, I always double check the units and I go back and I look and see. So when I wrote centimeters squared here, I was like, what the heck happened there? I had centimeters squared here as well. So I know I screwed up. So that's why it doesn't matter. And like you can see me, and that obviously I'm here teaching, I'm pretty good with numbers. But like I still go back. Like you should always go back and double check. You know the expression is in construction, measure twice, cut once, right? You don't do it the other way around, you waste money and you get inefficient anyway. Okay, hopefully you had not too much danger with that one. Perhaps we'll do a question now that's super easy. This is a question that most people could answer in their sleep, which is a rectangular box. So the question here is that we have excavation for a foundation for a condo, and the cavity is 95 by 63 by 20 feet respectively. The question is, how many cubic yards of earth have been removed for this excavation? So we're going to come back to this question in a similar way later in the second hour, but for this first hour, we're just going to work with a rectangular box. Because we know in real life that when you do an excavation, it's never true, it's never vertical. There's going to be sand that kind of does this, and I know that you know that there's a little bit of an angle there when you excavate, but we're going to just pretend it's a box right now, a rectangular box, or a rectangular prism if you prefer. So what's the formula for the volume? Because when you do these questions, sometimes I'm not going to tell you volume. You're going to have to decide what that is. And you know that it's a volume question because the question says cubic yards. See that? So I think Denny's a little bit ahead of the game right now, but yeah, no, that's very good. Denny, just hold your thoughts on that one. That's excellent. That's the answer that I have as well. I'm gonna put a little bit extra work in the decimals, but the volume of a box is length width height. Yeah, this is like a question that, again, on the easier side. But I said to you in this first hour, I'm gonna go easy on you guys. In the second hour, we're gonna play some jazz. So we have here 95 feet, 63 feet, and 20 feet. Now, I don't care if you put the units in the brackets here when you're doing your questions. The reason I put the units in the brackets for me was kind of like a penalty, like a foul in soccer or something. I made a mistake in the previous question, so my penalty is to go and put the units everywhere so that I don't screw it up this time. So that's why I put the units this time. It's just a little thing that I do when I'm working on measurements. If I screw something up, I do the extra baby steps. When I did this earlier on my calculator, I have an answer similar to what Denny had, which is 119,700 cubic feet. Now, Denny's answer is just as valid because his is to 3 significant digits. The reason that I didn't do that right away, though, yes, you rounded it earlier. The reason I didn't round it yet is because the question doesn't want cubic feet, it wants cubic yards. So now you need to do a conversion from cubic feet to cubic yards. So how many cubic yards in a cubic foot? Ooh, okay. So this is tricky. And you're not going to like me, but it's a little bit harder than that. So here's the issue, Denny, and anybody else that was thinking that. You're saying to do a 3. So if you go here and you say 1 yard is worth 3 feet. Okay, so see this fraction here? You should have been doing these in the previous math course, I hope. So hopefully you see what my issue is. Do these feet cancel? Do those feet cancel with these feet? Yes or no? No, they do not. They do not. And the reason they don't is because it's cubed. You see the cubed? It's not the 0.3, guys. It's this. There's a 3 here. It's cubic feet. This is linear feet, okay? This is linear feet, not cubic feet. So to be fair, you have to do it 3 times. So the factor is not 3, everybody. The factor is 333, which is 27. So when you want to go from cubic feet to cubic yards, you have to divide by 27. 27. If you divide by 27, let me write it again here. 119,700 cubic feet times, whoops, 1 cubic yard per 27 cubic feet. I don't really care if you did the spheres and the cones we did earlier. This question, if there's one thing you take away from today's class, is this factor of 27. Anyway, you get 4,430. Let me put the comma in there correctly. Cubic yards. And there you have it. I'm really, yeah, because it's to the power of 3. I know I'm not trying to like play games with you here, but this thing here does not look identical to that thing there. They're not identical. They have the same letters, but they don't have the same numbers. Think of it like a picture. This one has a mustache, and this one doesn't have a mustache. I don't care what the situation is, okay? These, though, are identical. And because they're identical, we can make that move to cancel them away. So keep that in mind, people. Do not fall into the trap of slashing out units because they kind of look the same. Okay. Hopefully I didn't get too what's the word I'm thinking of, abrasive with you this morning. You're very welcome. It's unfortunate that I don't get to have you for 2 courses back to back so that you get used to me, because the things that I get really passionate about are the things that are very subtle and unfortunately overlooked at times. For those of you that want to see, if anybody in this audience is interested in seeing a lesson that I've done in the past on unit conversions, there are videos that you know how I post these videos on my channel. There are other videos that I have from other courses, and you can email me and I'll send you the appropriate link for the unit conversion. I don't want to post the link directly on Blackboard because my fear is that you'll see that video and you'll think it's a lecture from this course and might not realize it's from another course because the course codes look similar, and you might get thrown off and think, oh my goodness, I missed an entire 3-hour lecture on something I never knew before, and or didn't know that we had. So that's why I'm not putting it directly on Blackboard. I'm just gonna, you want extra lesson, you can email me, I'll send you a link. Oh, look at this, it's a sphere, but it's not a sphere, it's half a sphere. So here's a situation where we have a surface area required, but we're given the volume. So this question's a little dirty one. This one's gonna kick us in the butt. So let's see here what the heck to do. This question won't be a 5-minute question. We're gonna go through this very carefully. So yeah, first of all, let's talk about a sphere. What is the formula for a volume of a sphere? Look me up with the formula for the volume of a sphere. You can go back and look in the table. You can Google it. But you should get, yeah, that's it. And you see, Denny, thank you. You see how Denny wrote that? He put the surface area of the sphere. We wanted the volume. But that's okay, because we're going to use that formula as well. But anyway, it's okay. What I was going to say actually is, you see how you typed it in there and it doesn't look like on the screen? That's okay. I can still understand what you're typing. So if you're in a test situation and you're trying to write something down and you can't communicate it by text, I can still figure it out. So don't worry too much about, like, you know, is the teacher going to understand that if I write down this, does the professor know that he means pi? Yeah, all that kind of stuff. I got you. Don't worry. I can navigate all that language. So that's a sphere. That is a sphere. You're very kind, Malik. Volume of a sphere. Sadly, my friends, we don't have a sphere, right? What shape is this in the question? It's a hemisphere. So this is what I was saying to you at the beginning of class. Sometimes you have to adapt to the situation. So we have a hemisphere, and spell today, hemisphere. So what you're going to do is you're going to put a 2 on top because it's half of a sphere. And this is the departure point for doing the question. So we're not using the table exactly. We're going to be using this formula. Let's highlight that maybe in red or something here. And we're going to find now how to proceed. Yeah, the full sphere would be 4 and the half is 2. Exactly. So what I did was this. If you want to see and to understand it better, I took this formula, and I can show you it step by step. I gladly will show you. You're dividing by 2. And then I'll go through it, baby steps, my friends. It's all good. You divide it by 2, which means you're multiplying by a half. And that's how I get that formula. Okay? So what happens is the 4/3, what's 4/3 times a half? You can do your fractions, it's 2/3. So that's how I achieve that formula. Now that we have the formula for the volume, I think we're in a fantastic position to continue because we know the volume of the hemisphere is given as 982. So we know 2/3 pi r cubed is 982. But at this point, you need to, excuse me, you need to determine what the radius is. And once you have the radius, then you can use the formula that Denny mentioned there, which is the surface area formula, but we'll get to that after as well. So how do you solve for R? Well, this is the hardest part of the question. This is the part that's going to make people sweat a little bit. So I'm going to give you a couple minutes, and I want you to solve for R here. Okay, I'm going to stop talking for 2 minutes. Okay, it's roughly been 2 minutes. I counted a minute and something, minute 50 or whatever. So anyway, how are we going to approach this question? Well, what you can do is you can take 2/3 of pi if you want and turn it into a decimal, which is what I did. This is approximately 982. And then you can divide both sides. Whoops. You can divide both sides by that number. So r cubed is equal to 468.87. This is in cubic, in this case, what, meters? This is in cubic meters. So then r is equal to the cube root. So we got to bust out the cube root operator of 468.87, which is 7.769 meters. And there you have it, my friends. We have achieved the radius for this question. Now, I need to tighten up my workspace here, so I'm just going to do a little bit of housekeeping because I need to do the surface area still with you. So let's do this. Sounds good? Hopefully that looks decent. We got everything we need there. Now we need to go get that surface area. So what's the surface area of a sphere? Well, that was in the chat. Thank you, Denny, by the way, for that one. Surface area of a sphere was area is 4 pi r squared. Unfortunately, we don't have a sphere here. We have a hemisphere. Can someone enlighten us as to what the formula would become? How do you change this formula to make it a hemisphere? Hemisphere area. Yeah, you just make it a 2. You don't need fancy math there. You need just a little bit of finesse, a little bit of quick wit there, because that's the answer that we're going to get. It's 7.7769 squared. I did this earlier, so I'll spare you the delay here. I got 569 square meters. As you may know, if you don't know this already, I'm the primary author, basically, of this book. So I've gone through each question line by line and scrutinized. So if you do find any typos or anything, albeit they're probably are very rare, because I've used this booklet for a couple of years now, please let me know. But anyway, I hope that you enjoyed these questions so far, and you've familiarized yourself again with a little bit about surface areas and volumes. 379. What? So what happened there? Well, no. So Shalon brought up something very nice, because the answer to this question is not finished. So what's wrong? What's wrong with this question? Nothing's wrong with our work so far is good, but the 569 that I reported is not the full answer. So what the heck's happening there? The answer is here. Let me find it. Include the base. We have to include the base. So the area of the base is pi r squared. And anybody have a number for that? I'm going to just tighten up this writing here. So my apologies, I kind of jumped the gun there a little bit because I hadn't completed my calculation. So you need to find these two numbers. This number here, which I'll put in red, plus this number here, gives us our final answer of 569. My apologies for that. I skipped a little bit too fast there. But that's the explanation. So the first number here that Shalon was mentioning, this number is 379. And then this number here is going to be, what, 190-ish, roughly? So 190 plus 379 gives you the 569. So thank you for the mention there. Unfortunately, sometimes you include the base of this hemisphere and sometimes you don't. So when would you include the base of the hemisphere and when would you not include it? Well, let's say, you ever seen those things? I've seen one in Scarborough along the 401 there, and it's like the golf dome where they have the indoor golf, but it's like a dome. It's made of canvas. You could estimate, for example, if it was a hemispherical dome, you could estimate how much canvas material you need to enclose that space, but you wouldn't need to put canvas at the base of it. For this thing here, for example, though, I gotcha. Yeah, you wouldn't be in a dome golfing if you're in the Caribbean or something, right? So maybe just for the protection from the sun. I don't know. But anyway, this shape here, for example, though, this could represent a storage facility or some type of an enclosure made of concrete. And if it was some type of like that, where you had, or something you wanted to, for example, treat, imagine this was an apparatus on a construction site that needed to be weather protected with a certain treatment, certain type of paint or chemical. You would need to cover the surface in its entirety, and that would require you to also treat the base of the shape. So that's why it's important when you look at questions in practice, or look at situations in practice, that you think about, do I need that part of the surface or do I not need it? So in my defense here, I should have read the question a little bit better, but the main thing is that you picked off the number and we were able to figure out the mistake. So that's good. Thank you. So at this point, there are some trickier questions that we can try. I'm just looking on the side and browsing here. I think what we'll do is take a short break, and then we'll resume class in about 10 minutes or so. So why don't you take a break? Let's just take a break until 11. If you want, you can start doing this question here. Okay, so for those that are curious or want to try something, I'm going to give you 15 minutes. I know that's a little bit extra than a normal break, but you can take 5 of those minutes and try question 2 on your own. So the question here is to find the total surface area and the volume of this roof. Just the roof, people, just the roof. So I'll join you back at 11 o'clock sharp, okay? let's give it a go here and see what's happening. In this question, can you tell me which of the numbers on the figure is not necessary or needed to solve this question? There's 4 numbers given on that figure. Which of those 4 numbers do you not need? Any volunteers? That is correct, Rocco. Very good work. That height, the height of the building, we don't care about it because we don't care about this part of the building. So this number here is actually useless to us. We're interested in the volume and surface area of this roof. So focus just on this region here. Now, when you divide the region up, you'll see that there are 2 rectangles because the roof is symmetric. There are 2 rectangles, and then there are 2 triangles, front and back, which I'm not going to draw the rear one because it's just going to get messy. The first thing I'm going to do is find the value of x, because it would make sense to find that edge length. And since you had a nice generous amount of time to set this up, I'm just going to tell you what I got for the edge length, and hopefully you got the same answer. So that was the edge length that I calculated when preparing this booklet here. So I got 7.48 meters. So hopefully you had a similar quantity. So what I did was I did the Pythagorean theorem. So for people that are curious, what did I do there? See the triangle here? There's a right angled triangle. I did the right angled triangle calculation there. So x is the hypotenuse of that right angled triangle. So we do this squared plus 3.74 squared, and then square root that. Now this base length here of the triangle, the base of the triangle here is half of 12.96 meters. Now that we have x, we are going to rock and roll and finish this question. I'm going to go for the surface area first. As mentioned in our little conversation, there are 2 triangles and 2 rectangles that form the roof. So I'm going to present my answer this time so that we can take a look at some new questions. So hopefully you have something similar. So I'll walk you through this. It looks like a little bit of writing, but please don't get too distracted by all the writing. Perhaps it isn't as bad as it looks. So let's take a look here. We have 2 triangles and 2 rectangles. The area of a rectangle is length times width. So let's just focus on this rectangle for a second, because rectangles are easier. Rectangle is length times width. Where is the rectangle? Well, here's the rectangle. There's the length, and there's the width. See? Length times width. Just bring that 4.28 up there. It just carries over to that edge. Half triangle, not 4. Are you talking about what I'm doing down here, Ram? I haven't gone that far yet. Yeah, you can think of it as 4 sides, yeah. I'm doing it as 2 triangles though, just because I want to do less work. So the triangle that I'm talking about, let me highlight that because we're both saying similar things. This is the triangle that I'm going to find the area for. This blue triangle is what I call area triangle, which is this thing here. So hopefully that clarifies it for both of us. And then the base of the triangle, yeah, that's why it's times 2. You see the 2 here? That's for the back side. This 2 here is for the back one, to double it. So we have the base, which is 12.96. And then we have the height, which I ran out of highlighters. Maybe we can drop another highlighter in there. I don't think we used green. Let's use green. So the height of the triangle is this number here, 3.74. So there's a lot of colors happening there. Hopefully I haven't made you dizzy, but that's how there's no factor of a half here. See, these twos cancel. I deliberately manipulated the formula first before actually going to do that. Oh yeah. So I'm only when you do this part here, you want to include the rear part because we assume the roof has a structure on the rear side as well. So yeah, it would be. It says it right here though, Ram. See, the roof has 4 faces. So that's why we include the rear. It's understood that the rear of the roof is part of the deal because it says there's 4 faces. So you do want to include the back side, even though it's not visible. So once you have those quantities, you virtually are done the question in terms of the surface area. And hopefully you took your time and you got an answer of 121 square meters. Finding the volume of this roof is a prism. So the volume is a prism shape. So for the volume, so remember we started off today's class talking about tables and different surface area and volume formulas that you can use. So in this case, the volume of a triangular prism is, I'm taking this straight from those notes earlier. So if you don't mind, I'm just going to present my solution here. And only because I gave you a 15-minute head start. So we don't need to write triangular prism there. Let me just cut that all out. So there you go. So in this case, the only thing you need to figure out is what L is. So L refers to the depth of the prism. So this is L right here. So L is equal to 4.82. And then the triangular part is the same numbers as here. I can highlight them the same way if you want. That's totally cool. Let's do that here. B, and then H was green. And there you go. Don't worry, my friends. This question's probably the most annoying one that we're going to do today. And I promise you that the rest of the questions we do, they are going to have a bit of tricks or whatever to them. But this one's by far the most annoying one. I'm not a fan of combo questions. What I mean is, I'm not going to give you a test question where I give you a shape and say find the surface area and the volume. I find that very irritating when you have to do 2-for-1s on questions. On an assignment, maybe I do that, but not on a test. On a test, my questions will be very acute, very direct. I'll say, get the volume, get the surface area, get this, get that. I'm not going to say get this and this and this and this. What are you, grocery shopping? No, we're not going to do that, okay? If I want to give you a grocery list, I'll send you for groceries, but not in a math test. I'll tell you, if I can find the test, I'll look for it somewhere. I have it somewhere on my computer. Like I scanned all my notes from university back in the day. I had an exam once. I'm not kidding you. I will find this exam and show it to you. I had an exam once. It was 2 questions. Question 1 was just question 1. And then question 2 was, and this was an exam, a 2.5-hour exam. Question 2 was parts, A, B, C, D, E, F, G, H, I, J. It had 10 parts to it. And the parts, yeah, I know. The parts were cumulative. So if you screw up part A, then you're toast because the rest of it's all garbage. I'm not kidding you. True story, people. True story. And don't even get me started. Don't even get me started on that one. I was not very happy about that exam because I made a mistake on like part B. No, what happened was I answered the questions, but once I got to part J, I know for part J the answer had to be 0. But when I got to part J, I didn't get 0. So then I knew I made a mistake earlier. So I went back and I retraced my steps, and I found out that in part C, I made a small mistake somewhere. And of course, that error carried through the whole question. So I put up my hand and I told the professor, I go, I know I made a mistake in part C, but I wasn't able to realize if that was a mistake or not until I got to the end of the exam, part J. And he's like, well, you can go back and do whatever. So I went back and I spent the last half hour just trying to like repair the damage. I was very, very, very upset. I don't care about the number, the grade, but I was upset because it's in my opinion, a poorly designed exam. An exam should not, and especially physics or a quantitative exam, should not be one question or two questions with 10 parts to the question that are interconnected. That's more like a case study or a project. Yeah, let me get me started there. From what I remember, I was going into the final exam with a mid 90, and I finished the course with an 86. Now 86 is or 87 or whatever I got. It was a good mark in an aerospace course. That's a good mark. But I went from a mid 90 to an 86, which probably means that I got like a B plus on the exam, which royally pissed me off. But anyway. Yeah. Well, I mean, everybody has their standards, right? And their expectations on how they want to do in a course. So all of these, I'm not trying to push some negative stuff on you, but all these things that happened to me as a student, anything that was like I didn't feel was just or fair, I said to myself, if I ever become a professor, I'm not going to do that garbage to people. I'm not going to do people like that because that's not right. Anyway, no. Just justice, my friend. You're very kind, Shalon. I'm all about the right or wrong. That's how I am. You know, you gotta do things correctly and with honor. Honor is the word. Okay. Yeah, let's do this one here. Let's do this one here. This one's a little bit crusty. This one's a little bit crusty. You're not gonna like this question, but it's pretty involved. I'm just thinking about how to best deliver this answer. It's a long question. Um, yeah, it's actually quite long question. So it says find the surface area and the volume of this shape. So I'm gonna talk to you about prisms. So let's go back here to prisms, and specifically we're going to talk about cylinders. So you can find the area of a cylinder like this, but that figure that I showed you is not a cylinder. It's a hollow cylinder. So that's key, people. It's a hollow cylinder. So when you look at these two formulas, they both actually are useful to this question. This question, just so you know, this is not a test question. This question is more of an assignment question. There's too many intricate things here, and I want your test to be something that's more breadth than depth, because it's only an hour and a bit, the test, and not too many questions. For those that I told you at the beginning of class today that the test is roughly, it'll be either 6 or 7 questions, but it'll be comparable to the first test in terms of everything else. How long you have to write it, the process is all the same. So anyway, here we have We have a cylinder that is to be treated with a sealer, and we have to treat the inner walls, the outer walls, and the top and bottom surfaces. The question is also to find the volume. Now, the volume is actually very easily calculated. You can do it two different ways. You can, for the volume, you can take the full cylinder and then subtract the inner cylinder. You can also find the volume by doing this general formula, which is to find the area of the base. The area of the base in this case is this ring. So it's not a full circle, it's kind of the difference of two circles. So let's see what we can make of this. To assist us with this question, I'm going to draw a cross-sectional view of the object. So this is looking from above, or from the cross-section. You have a ring. And then I'm going to put two arrows here denoting RO and RI. So what are RO and RI? Yeah, you're on the right track, Denny. So I'm just going to make a couple definitions here. The outer radius and the inner radius. So these are just a couple of definitions that are going to assist us with this question. The outer radius is RO and the inner radius is RI. So I'm going to just put down the numbers here. These should be quick for everybody, hopefully. It says here that the inner diameter is 314 and the outer diameter is 398. So the outer radius is 398 divided by 2, which in this case is, I'm going to do, let me see here, 199. Sorry, I'm just reading ahead in my own personal notes about stuff. So we're going to go with meters. We're going to go with meters, and I think you can appreciate why we would want to go with meters, because the question involves density later, so it's better to have the volume in cubic meters. So that's going to be 1.99 meters. Let's speed this up a little bit. The inner is 314 divided by 2, which is 157 centimeters, or 1.57 meters. So once you have the outer and inner radii, then you can go and get the volume of this shape. So I'm going to go right for the volume. I'm going to go for the gold. You can go with the formula here, or you can do the difference of the two cylinders. To make your life a little bit more simple, I'm going to do the volume difference. So the volume is going to equal the volume of the outer minus the volume of the inner. So cylinder is pi r squared h, as you can see right on the formulas provided. And that's going to be pi r outer squared h. And then take away the inner volume. If anybody's getting really worried about this one, like I said, this is way too much writing. Maybe just the volume itself, but not the volume and the surface area on a test for one question. So pi r outer squared, so 1.99 squared. The height of this thing is how much? It's 5.74 is given. And then we have pi 1.57 squared, 5.74. So eventually, when you crush all that material together, I got the following. I got 27.0 cubic meters. Can someone confirm, please? Any volunteers to confirm this is correct? Thank you very much. Let me just format it a little bit nicer, make it look a little bit more presentable. So we've now found the volume of this shape, which is fantastic. But the question's asking for what is the mass of the cylinder. So let's go for the mass as well, because mass and volume go together. You may know the formula for density. Who remembers that density equals mass divided by volume? Anybody remember that formula from somewhere in the past? Good. So we can use the formula, but you don't have to know this formula. If you don't remember this formula, that's okay. What I'm going to do is I'm going to shrink it and I'm going to gray it out. Gray means, you know, for me it means sorry, where's my text color? Gray means that you don't really need it for the question, but you do need to spell it correctly. Sorry. Anyway, the way that I'm going to do the question is strictly with unit conversions. So I'm just going to do this number here, and I'm going to multiply by the density. That's just kind of what we did earlier with the cubic yards question. So we can multiply here by 2,400 kilograms, and you see how the meters cubed cancel? That's how you rock and roll that thing out. So that's 64,800 kilograms. So anyway, that completes the volume calculation. Yeah, so I canceled out the meter cubes. So just to reiterate what I'm saying there, I'm saying is you don't need this formula. You can just do what I did at the bottom here, which is just use the units as you can cancel them out anyway. But that question for the volume is this question as you see it right now is a beautiful question for a test, the way it looks now. What I don't want to do to you on a test is give you this plus the surface area, because then it becomes a marathon question and it reminds me of like just giving you A, B, C, D, E, F, G for a test. I don't like that kind of stuff. So to find the surface area, there are various ways you can approach it. I'm gonna do the surface area just kind of, we can do it different ways. That's the problem here. I don't want to really confuse the issue too much. I might just show you what I did for the surface area on Blackboard, like on a posted solution, because it's going to take up a lot of time. So let's just see here. The inner walls and the outer walls are both treated as well as the top and the bottom. Okay, so I'm just going to walk you through it the way that I would do it, more like a puzzle, like a jigsaw puzzle. So let's do that here, okay? I'm just going to show you what the setup is, but then you can put all the numbers in later if you don't mind, because I want to move on to a very important question. I was debating about doing this question with you today, but I thought this would be like our big case study question. So the surface area, let's go with some pieces here. We have the top, the bottom, the outer wall, and the inner wall. So that's what we're working with. Is everybody cool with that? Let me know in the chat if you disagree with what I have here as a list. That's kind of like the jigsaw puzzle that we're putting together here. We have the top, the bottom, and the outer and the inner wall. So if you're wondering how do you machine this or kind of patch this together, maybe we're looking at this formula right here, okay? So when you talk about the top and the bottom, you're talking about this stuff. The yellow part of this formula refers to the top and the bottom of the cylinder, whereas this part here is the lateral part. So I'm just going to put in blue here. I'll just write down the word lateral because it's the lateral area or the side area if you want, the wall, the side wall. So that's the lateral area. that part there that I've denoted in blue is the lateral area. So if we go with the outer wall, I'll start with that. Then that would be 2 pi r outer h. And the inner wall would be 2 pi, whoops, r inner h. Top and bottom, it's kind of funny because it's hollow. You see how it's hollow? You got to subtract 2 circles. So you're going to do pi r squared minus pi r squared with the respective inner and outer radii. And the bottom and the top are the same. So this is actually the same formula twice. So when you calculate this one, just copy the number for the second one. So if you don't mind, I'm just going to let you do that as an exercise on your own. The answers are posted in the booklet. As you know, when you scroll down later in the booklet, when you go to the end of the booklet here, they are upside down, but they are there. It's actually kind of funny because the author of the other books, Professor Waters, who's now retired, would put the answers upside down so you wouldn't get nosy to peek. You want to really, you have to kind of do the extra step there anyway. So I'm just going to put your total, and you can check the answer on your own if you don't mind. You should get a surface area of 138 square meters. I don't remember if the question mentioned the cost associated here, so let me take a look. No, there's no cost associated, so the question's done. But a follow-up question could have been, okay, it costs $75 per square meter to treat this apparatus. So there you go, my friends. A really annoying question, and unfortunately, you can't do much with it anyway. Yeah, it's a long one. It really just brings to light the issue of you trying to just take a formula like this and shove it in. You know what I'm saying? It's like going to buy a pair of shoes when you're a size 10 and you want to stick your foot in a size 8 shoe. You think that the formula is going to fit the size 8 shoe. It's not going to fit. You got to take the formula, you got to take it apart, and you got to figure out what works and what doesn't work. Yeah, but honestly, if you're, in my honest opinion, even though this question is a harder question, I still like it over the house question. The house question's annoying to me because it's I don't know. It's just personal, I guess, just personal preference. We're going to cover one more question that's very important. I'm not saying it's important for a test. I'm saying it's important for you and your program. Because when I designed this booklet and set up the material for this course and other courses, as you know, I'm the coordinator for the math courses at school, at your school. I ask professors in other years, in second year and third year, or even in fourth year for the degree students, and I say, hey, what stuff would you like me to show the students in first year to get them better at their measurement and mathematics and physics and whatever else? And one of the professors, who was an estimating professor, said, I want them to understand how to find the volume of this. Now, what the heck is this? Let's take a look at these views here. So this is a more realistic representation of an excavation. So remember we did a question earlier that was an excavation, and I said find out how much material, earth was removed. And the funny thing with that question was that the shape was a rectangular prism. It looked like that. Remember that question? We did it earlier today. But as you know, in real life, it flares out. And the reason it flares out is because in real life, soil is not like concrete. Soil is going to slide and it's going to form a sloped surface. So this is the side view of the excavation. You can see here that there's a sloping edge now. Instead of it being true, it's on an angle. And that's what I'm trying to get you to understand here is how do you find the volume of this excavation when you have this really funny looking shape? And for that purpose, there is a formula that you can use to do that. And unfortunately, I don't know if I have the formula. Here it is. I thought I had cut this slide out here, but here's the formula. So it's called the frustum. Do you remember us talking about frusta or frustums? Frustum of a cone and a frustum of a pyramid. So that shape that you see there is very close to this shape, which is called a frustum of a pyramid. See, what is a pyramid? You know what a pyramid is. A pyramid's anything that has this apex shape to it, like that. But a frustum is when you cut the top off. And if you cut the top off, you end up with this funny looking shape. So when I was preparing this booklet, I was researching different shapes. Yeah, we mentioned it briefly earlier in the course when we were talking about naming three-dimensional shapes. So if you dig back into chapter 2, I think, we had discussed it briefly there. Anyway, this formula, this guy over here, this question, it could be really nasty if you try to break it up into little pieces. So in this question, there's two parts. There's A and B. Part B is where you want to just do it like patchwork, like you just break it up into pieces. Little triangular prisms and rectangular prisms and little pyramids in the corners. It's a disaster. I do not recommend that you do part B. Okay, if you really have free time, go for it. But part A is the way we're going to solve it. And what's beautiful about this formula is that in order to find the volume of this figure, you don't actually need that many measurements. Take a look how beautiful this formula is. What does the formula require from you? It's right here. That's the formula. It requires the areas of the top and the bottom. Yeah, part A is the formula, and part B is to do it like Lego. I'm not gonna part B. We're not doing part B in class. It would take us like 20 minutes, just part B alone. And all you need is the area of the bottom and the top. It doesn't matter which one is which because as you can see, they're added and multiplied here. So the index 1 and 2 doesn't matter. You can have area 1 and area 2 or area 2 and area 1, etc. And also you need the height. You need the height of this frustum of a pyramid. So I'm going to take that formula and we're going to just steal it and solve the question. Here's the question, part A. Okay, sorry, just a second. Like I said, I'm working on 3 different desktops today, so it's kind of fun. It's kind of fun hearing me pause, or not hearing silence for me as I'm pausing to think about which tab to use. So there you go. So we have everything we need, I think. If you can tell me what the what the height is, and the area of the base and the area of the top, then this question is done. So let's take a look. Okay, so Shalon is on point there. The height, oops, let's do the math formatting. The height is 40 feet. Very good. What's the area of 1? I'm just gonna actually let me just mention here. This is the height. I know that you know height is height. That's ridiculous. I'm not trying to insult anybody here. I'm just gonna say this is the area of bottom. Just excuse me for a second. Sorry. So yeah, it's 120 by 120 because it's this inner rectangle, this inner square. So it's 120 feet squared, which is 14400. Thank you, Shalon. Thank you, Denny. And then the area of the top is 200 by 200. So these are really just mental math. There's a lot of mental math in this question, which means that you can actually put out a good estimate without too much stress. Like that. Now we're good to go. We can go to this formula now and toss in these numbers. So the volume is going to equal h over 3, so 40 over 3. Then we have here, all right, and from there, I think we're pretty much ready to roll here. So I don't know about you, I got 1,000,000 and change. Can someone confirm they got 1,000,000 and change? 1,000,000 something. Just doing a little mental math there. I'm around 1,000,000 on this one. 1,000,000. I'm looking at my answer now. I got 1,000,000 and okay, 45,333 roughly. That's the volume in cubic feet. Awesome. Are we done the question? No, we're not done the question. What's missing, Shalon? What am I missing? We got the volume. That's good to go. But what's wrong? Yeah, we got to divide by 27. So the reason that Shalon mentioned 27 is because we need to go to cubic yards. So let me just write that on a separate step here. So I'm not going to show the intermediate work here because I showed you this in the first hour. I'm just going to say 1 cubic yard is equal to 27 cubic feet. So if anybody's not sure why it's like that, it's because we explained it in the first hour. So if you go back to one of the earlier examples, it's a cubic foot is not the same. Sorry, it's not a 3-to-1 ratio. Yeah, this formula is beautiful. It's actually one of the nicest formulas I looked up in my research and in preparing this workbook. Anyway, can we have an answer on this? Yeah, the longer way, you don't want to see it. I'm going to show you my answer the longer way. Like I'm just going to put it to the screen, but I'm not going to discuss it because it's gonna, like I said, take 20 minutes, and you're not gonna gain anything from it. It's just basically a kick in the rear, okay? Honestly, it's just a kick in the rear. It's not even a learning experience. It's like I consider it punishment. That's part A. I'm glad that you appreciate the formula because it definitely is a game changer. I'll just leave this on the screen in case anybody is just taking down this information. What I'll do is I'll screenshot my solution from from my personal notes, and I'll just dump it on the empty slide here so that you could see how you would have solved part B. So I'll just give you another couple minutes about that. And then I can talk to you briefly about the test for the last 10 minutes, and you can be free to go and enjoy your weekend. Of course, remember you have an assignment due on Friday, today that is, at before midnight. I haven't checked the statistics how many people have handed it in, but hopefully the turnout has been good because, as you know, deadlines are deadlines. Yeah, I'm glad that that your perspective changed, Malik. It's these assignments, they're really just about me pushing the boundaries with you and seeing where I can stretch your imagination and challenge you a little bit. So here's part B. I'm not answering part B in detail. So again, I'm not trying to be lazy or like slow or whatever. I just want to have it on paper for those that want to see how you would answer this later on Blackboard. Be my guest, okay? I'll put the answer for my personal notes here, but you're not responsible for it to do it this way because honestly, this way is not fun. So here's my answer the other way. I just put it here. Hopefully the numbers are correct, but maybe there might be a symbol. These are my personal notes, so they're not really proofread that well. They're just notes that I write down for myself to help you teach you in the class. So there it is. I've kind of chopped it up into pieces. I ended up getting the same answer within I was within 6 cubic yards. See, we got 38716, but here I got 38710. So I was off by 6 yards. and I attribute the 6 yards to an accumulation of round-off error. Because every time you round something, and then you round other stuff, and you round other stuff, and then you add rounded stuff together, it degrades the answer. This is another reason why the formula that I showed you is better than breaking it up into pieces, because the more steps that you impart in a solution, the more that the rounding errors build up. That's right. You want to have clean, pretty, simple answers. You do not want to have this kind of stuff. Nothing's wrong with this. There's nothing wrong with this answer. But I'm just saying, under pressure, maybe you use this, or maybe you don't know that formula. And exactly that. But that's why we have factors in construction, like to account for overages and waste of material that might be involved in certain situations. Like that's why you always order a little bit extra, 10%, 15%, whatever you allocate in a typical estimate. I'm going to stop the recording now. Wish you a lovely weekend, but let me talk to you about the test first. So let's stop this recording.